Hello friends, this video is created by Siddharth Upadhyay, founder and creator of PrepWings. Log on to www.prepwings.com for complete free course videos. Okay, so in this video we'll talk about cyclicity. Cyclicity is a very important concept to find the units digit of a given number. So for example, a question asks us to find the units digit of 2 raised to power 46. So we'll use the concept of cyclicity to solve this question. So over here, first we understand how cyclicity works. So over here we have shown the values of 2 raised to power 1 till 2 raised to power 12. Okay. So if you closely observe these values, you have to see a pattern over here. Looking at the pattern, you say 2 raised to power 1 ends in 2. 2 raised to power 2 ends in 4. 2 raised to power 3 ends in 8. 2 raised to power 4 ends in 6. Then 2 raised to power 5 again ends in 2. 2 raised to power 6 ends in 4. 2 raised to power 7 ends in 8. And 2 raised to power 8 ends in 6. So basically 2, 4, 8, 6 are getting repeated over and over again. Okay. So 2 raised to power 9, 2 raised to power 10, 2 raised to power 11 and 2 raised to power 12 will also end in 2, 4, 8 and 6 respectively. Okay. Thus, what we observe that the units digit of 2 to the power is getting repeated after an interval of 4. Thus, we call the cyclicity of 2 raised to power any number as 4. So, if you look at it as an example, 2 raised to power 3 ends in 8. Then 2 raised to power 7 also ends in 8. And 2 raised to power 11 also ends in 8. If I add 4 to it, which will become 2 raised to power 15, that will also end in 8. Okay. So if you look at another example, 2 raised to power 4 ends in 6. Then 2 raised to power 8 also ends in 6. And 2 raised to power 12 also ends in 6. Okay. So the units digit is getting repeated after an interval of 4. So the cycle for the power of 2 is shown over here. Okay. So 2, 4, 8 and 6. This is called as the cycle for power of 2. Okay. Okay. Now we will look at the example to find the units digit of 2 raised to power 46. Now over here we show the cycle for power of 2, which was 2, 4, 8 and 6. Now 2 raised to power 4 ends in 6. Now if you look at it, 2 raised to power 44 will also end in 6 because 44 is a multiple of 4. Okay guys. Then 2 raised to power 45 will end in 2 because after 2 raised to power 44 the cycle will have to move to 2 raised to power 45. So cycle moves from 6 to 2. Alright. So 2 raised to power 45 ends in 2 and then 2 raised to power 46 will end in 4. Thus 2 raised to power 46 ends in 4, or the units digit of 2 raised to power 46 is 4. This is how we calculate units digit of 2 raised to power 46. Now similar to 2, cyclicity of other numbers can also be found. So over here we show the cycle of 3. The cyclicity of 3 is again found to be 4, which is similar to 2. Okay, you don't need to memorize these cyclicities. You can find the cyclicity. So we have shown how to find it in the example before, wherein we showed how to find the cyclicity of 2. The same thing can be used to find the cyclicity of 4 or cyclicity of 3 or cyclicity of 7, any number. Okay, so over here we have shown the cyclicity of 3. Now the question asks to find the units digit of 3 raised to power 67. So now we show the cycle of 3. So the cycle of 3 is 3, 9, 7 and 1. Okay. So 3 raised to power 4 ends in 1. Okay. Or any multiple of 4, 3 raised to power any multiple of 4 actually will end in 1. Thus 3 raised to power 64 will end in 1 because 64 is a multiple of 4. Okay. Then 3 raised to power 65 ends in 3 because of the cycle from 1 goes to 3 back to 3 at the top. Okay, and then 3 raised to power 66 ends in 9, and 3 raised to power 67 ends in 7. Okay, thus the units digit of 3 raised to power 67 is 7. Alright. Now we look at 4. The cyclicity of 4 is 2. Okay, and the cycle is shown over here. So 4 raised to power 1 ends in 4, 4 raised to power 2 ends in 6. Okay, so what we observe from this is, if the power of 4 is odd, then the result will end in 4, or if the power of 4 is even, then the result will end in 6. Now looking at cyclicities of 5 and 6. So the cyclicity of 5 and 6 is 1. What it means is that 5 to the power any number, like 5 raised to power 1 or 5 raised to power 2, which is 25, or 5 raised to power 3, which is 125, all these number will always end in 5, or will have the units digit as 5. Similarly, 6 raised to power 1 is 6, 6 raised to power 2 is 36, 6 raised to power 3 is 216. All these numbers are ending in 6. So 6 raised to power any number will always end in 6. Okay. Now looking at 7. 7 has a cyclicity of 4, and the cycle is shown below. So the cycle of 7 over here is shown as 7, 9, 3 and 1. Okay. Now similar to 7, cyclicity of 8 is also 4, and the cyclicity of 8 is shown over here. So if you look at the cycle of 8, it says 8, 4, 2 and 6. Now looking at cyclicity of 9, cyclicity of 9 is 2. It is similar to 4. Okay, so if the power of 9 is odd, the result will end in 9, or if the power of 9 is even, then the number will end in 1. Okay. Now we'll do a question over here. The question asks us to find the units digit of 7 raised to power 34 multiplied by 6 raised to power 41 multiplied by 8 raised to power 63. So first we will find the units digit of 7 raised to power 34. We'll use the concept of cyclicity to do that. So the cycle of units digit of power of 7 is shown here, okay, which is 7, 9, 3 and 1. Okay, so that would mean that 7 raised to power 32 will have a units digit of 1. 7 raised to power 33 will have a units digit of 7, and then 7 raised to power 34 will thus have a units digit of 9. Okay, so the units digit of 7 raised to power 34 is 9. Then we'll look at the units digit of 6 raised to power 41. Okay, since we have seen before that 6 raised to power any number will always end in 6. Thus the units digit of 6 raised to power 41 is nothing but 6. Okay. Then units digit of 8 raised to power 63 can be found using the concept of cyclicity again, and the result comes out to be 2. Now to find the units digit of 7 raised to power 34 into 6 raised to power 41 into 8 raised to power 63, what we do is we multiply the units digit that we found before. Okay, so units digit of 7 raised to power 34 is 9, units digit of 6 raised to power 41 is 6, and units digit of 8 raised to power 63 is 2. So we multiply 9, 6 and 2, and we get the result as 108. Thus the units digit of 108 is 8. Okay, so our answer is 8. Okay, so what we found now is that the units digit of 7 raised to power 34 multiplied by 6 raised to power 41 multiplied by 8 raised to power 63 is nothing but 8. Okay. Now we'll do another question. We have to find the units digit of 143 raised to power 25. Okay, so we have seen the cyclicity of 3, 4, 7, 8 like individual single digit numbers basically, so to say. Okay, but this is a 3-digit number. Okay, so how to approach this question? In this question you don't need to find the cyclicity of the entire number like 143. Okay. What this question boils down to is that units digit of 143 raised to power 25 is actually equal to units digit of 3 raised to power 25. Okay, and the units digit of 3 raised to power 25 can be found using concept of cyclicity. Okay, So the cycle for 3 is shown over here, which is 3, 9, 7 and 1. So units digit of 3 raised to power 25 is found to be 3 using the concept of cyclicity that we did before. Thus the units digit of 143 raised to power 25 is nothing but 3. Alright. Now we'll do one final question. Over here we have to find the units digit of 54 into 26 into 657 into 99. Okay. So now if we look at it, all the numbers have power 1. Okay. So we don't need to worry about cyclicity over here. What we need to do is just take the units digit of each number individually, multiply them and find the units digit of the final result. Okay. Thus units digit of 54 into 26 into 657 into 99 is equal to units digit of 4 into 6 into 7 into 9, okay, which results in 2. Okay. Thus the units digit of 54 into 26 into 657 into 99 is equal to 2. Okay. So this is about the concept of cyclicity. Okay guys, thanks a lot for watching this video.